So the last issue that we'll talk about as it relates to air pollution is the ozone layer. But this isn't the ozone that's at the ground, so not ground level ozone. This is the ozone that's found higher in our atmosphere. So this ozone layer is a little bit higher, and it serves an incredibly important function. It protects us here on Earth, whether it's humans, animals, plants, etc. It protects us from ultraviolet radiation. So when the sun shines down, not only does it give us heat, but it has ultraviolet radiation. And if you've ever looked on a suntan or sun lotion, it will say protects from UVA radiation. UVA is ultraviolet radiation A. A is the least worst. It is the safest, so to speak. But you've heard about skin cancer and you know about like tanning and sunburning, that even though UVA might be the safest, it's still not safe. There's also UVB, which a lot of the ozone layer protects us from. There's also UVC, but UVC is completely blocked. And it's because of this ozone layer that we're protected from some of the sun's harshest rays. But there's a problem. We destroyed a lot of that ozone, a lot of that good ozone. There was a chemical called CFCs, that is chlorofluorocarbons. So again, this C is for chlorine, fluorine, and carbons. And we were releasing them for refrigerants and for air propellants. So think of old AC units, even in your cars, old vehicles, old fridges, and then also in things that spray, that have an aerosol spray. You can find CFCs in those as well. And we were using them everywhere. They were blasting out of our AC. We were putting them, in our hair for hairspray. And we learned that those CFCs actually break down that ozone. These substances are also greenhouse gases, and they're pretty strong greenhouse gases. But on the wide scale of things, as far as a greenhouse gas, there wasn't that many of them, and they broke down pretty quickly. But when it came to the ozone, they did a really good job in breaking down the ozone. But it's not the ozone worldwide. It's actually ozone really under and around Antarctica. In the weekly guide, you'll watch a video that kind of explains that a little bit better. But essentially what happens is those CFCs, those chlorofluorocarbons, they get transported around Earth and they get circling and circling, circling, and they get stuck over Antarctica. And they kind of stay there. And what happens is you have chlorine from that CFC, you have this ozone, and what happens is in certain times of the year, so in September in Antarctica, they're pretty much in sun all the time. And that sun has tons of energy in it. And that energy kind of forces that chlorine and ozone to mix up molecules. And what it makes is not ozone, is the point, is that we had ozone and we had this chlorine and something happened and it broke that ozone down. And what we've been seeing is that the ozone layer is thinning. We've called it the ozone hole. Here, if we look at September 1979, blue represents lower levels of ozone. And the rest of the world's doing pretty okay. But in Antarctica, you already see a little bit of thinning. Here is 89 and 99 and 2009. You see how huge this ozone hole is. Now I do want to emphasize, although I keep saying hole, and that's what the media says, it's not a hole. There is still ozone in this area. It's just very, very thin, especially when compared with the rest of the world. But it is getting better. We'll talk about more why in just a second. Here is the ozone from September 2017. The hole is a little bit smaller, and you see it's not as purple in here. Purple represents the thinnest, and it's more like blue purple, so it is increasing in concentration, which is really, really awesome. The reason that ozone is coming back is that in 1989, all the countries around the world got together and signed the Montreal Protocol. This protocol was brought to you by the United Nations, and all the countries ratified it, meaning all of them said, yes, you know what, we agree with the rules set forth by the United Nations. And the rules essentially said, get rid of these ozone depleting substances like our CFCs. So all these chemicals in our hairsprays and our refrigerants were going to be phased out and no longer used, which was great. And it worked, and it's currently working. We're seeing the effects of this ban. Now, the ozone layer, although it is getting better, it will still take a while for it to completely come back. Here, what we're seeing are the levels of chlorine. So again, that chlorine is from the CFCs. Here you can see it peaked in 1990, and this past 1989, we're already seeing a decline in our chlorine, which is awesome. It'll probably take for about 2050 to 2070. It'll still be a while before those chlorine is all the way low and for that ozone to be completely restored. But so far, we're on the right track and it's working. And this is a really cool example of how literally the world came together and addressed an environmental problem that we can fix and that we've fixed. We're just kind of waiting for it to fix. But how did we get something like that to work? How did we get all countries around the world to agree to this? You know, climate change is such a big deal these days, and it seems to be really hard to get any real progress going. So how are we able to pass this? And we passed it actually pretty easily. Well, one, there was convincing evidence, and there was dramatic evidence. You know, looking at these two images, very easy to see. Lots of ozone, not a lot of ozone. Yes, there's a lot of evidence of climate change, but we're not at worst case scenario yet. We can't say, oh, if we look 10 years ago, here's what it looked like, and here's what it looks like now, because climate change takes a lot longer really to have an effect. So because there was very clear, very dramatic evidence, it got people behind it. Also, not a lot of companies were affected. It's very few industries that were making those CFCs. There were people who made refrigerators, people who made air conditionings, people who made air spray. That's not a lot of people. If you compare it to climate change, like everyone is affected. Anyone who drives a vehicle, anyone who has electricity that is not from an inexhaustible resource, they're all affected. Also, because there are so few people that were creating these gases, they were also able to find pretty cheap alternatives. So it's like, oh, we can't use CFCs. That's okay. We'll use this instead. And this thing doesn't deplete ozone. And then finally, there's also a very easily identifiable consequence. If there is no ozone, then skin cancer will skyrocket. And that was a very easy cause and effect. Climate change, on the other hand, if we don't do this, well, this might happen, or this might happen, or this might happen, and we're not entirely sure because we don't know yet. So because of this is why something like the Montreal Protocol was so easy to pass and has been so effective. The reason we don't have legislature like that yet with climate change, although we are getting there, I will say we have made, as a globe, we have made some good strides. The reason we're not there yet is just because we don't really meet these different criteria when it comes to that. So in summary, with the ozone layer, there were these chemicals, the CFCs, that were breaking down ozone over Antarctica that caused a very dramatic thinning of that ozone layer. This ozone is good ozone. It protects you and me from ultraviolet radiation. Because it was so clear the importance of this, we were able to ratify a treaty across the world to ban these substances, and we are already seeing the positive effects of that ban. So really great example of this kind of environmental regulation working worldwide.